All right, so what we have is this is chapter 10, and what chapter 10 is looking at is we're starting to get into the idea of how do we measure the risk associated with the transaction. All right. And so the idea is that a number of banks during the financial crisis in '08 used to do something called value at risk. And what they were doing was stress testing. And they said, hey, what if like the worst case scenario happens and something like this occurs? And they said, well, I don't know. I mean, the worst case scenario is obviously aliens coming down and taking over the world and no banking. Okay. Well, let's go to not the absolute worst case, but kind of like what would a bad case scenario be? And so they had to define it. And what happens is they end up using something called a 95% value at risk measure. Now, to give you an idea, I'm going to go ahead and start sharing the screen. And this is just the chapter 10. I think it's just called chapter 10 example in class if you're looking at it from your Moodle document. And basically it says, hey, we've got a company that has 515,000 euros coming in. So this is going to be accounts receivable. And they're coming in 60 days. So if you kind of see, here's where we are. Okay. And what we're going to see is if the euro right now is trading at $1.36. Okay. But we're not actually going to get the money for 60 days. Then we've got to figure out on day 60 what's going to happen to the euro. Okay. Now we can see lots of crazy things happen over time. Things go down, they spike up, they go down, they go up, they go down, they go up. And we're trying to figure out where it's going to hit in 60 days relative to where it's at now. Okay. Now, it could be anything, I guess, theoretically. If the euro is trading at $1.36 now, it could be trading at 10 cents or it could be trading at $3, but that's not really likely. Okay, so what we do is we go back and look at history and we see how volatile something is. That's not very good. We see how volatile something is and we can kind of put it on a probability distribution. Okay, now just to give you an idea about probabilities and how we define risk, if you click on, there's something called chapter 10 binomial distribution. Okay. Are you seeing an Excel screen come up on my share screen?
Yeah.
Yes.
Yes. Okay. All right. I didn't know if I clicked back and forth, if it went to a different, if it logged out of, or what it's actually sharing. So anyway, what you can see is this is like throwing 100 pennies up in the air. Okay. Now 100 pennies is a binomial distribution. And what we want to figure out with this binomial distribution is what's the likely outcome? What's the likely outcome when you throw 100 pennies up in the air? That is, we want to figure out how many heads and by default how many tails we would have. And most people would say the most likely outcome when you throw those 100 pennies up is that you'll have 50 tails. Yeah. But they don't really mean that that's what's going to happen. It's just the one that has the highest probability of occurrence. Because realistically, what could happen? You might get 48 or 49 tails or 50 tails or 51 or 52 or 53. So if we look at this probability over here, this is the probability of an actual event occurring. So the probability of getting exactly 50 tails is only like 8%. So what does that mean? Well, it means that it's also likely you could have somewhere around 50 is most likely. Okay? Now let's look at the two extremes. What do you think the probability of having all the coins fall and be all heads and no tails? or vice versa. It's possible. It's like 0.00 to the 15th power percentile. So it's like 17 zeros and then some number. Okay. What does that mean? Realistically, even getting something like, and I didn't show you all the outcomes, but even something like getting 30 tails and 70 heads, it'll come up like 0.002% of the time. Okay? So 2/1000% is how likely that's to occur. What's the most likely? Getting 50. Okay? Oops. But actually getting exactly 50 only occurs about 8% of the time. So what we can look at and what we can see is getting 50 heads is the expected outcome, but we can also figure out something called the standard deviation. And the standard deviation tells us basically what's the probability of being between two numbers. So just to kind of simplify it a little bit, getting 50 tails is the expected outcome, but it has a standard deviation of 5. What does that mean? It means in a normal, and it is normally distributed, in a normal distribution, if you go out plus or minus 1 standard deviation, you're going to hit about 68% of the probabilities. Anyone know what happens if you go out 2 standard deviations? 2 standard deviations would encompass how much of the probabilities? You have to unmute yourself to answer. All right, how about a call on someone? How about Tracy? What's 2, you gotta unmute yourself. What's 2 standard deviations encompass?
I don't know.
Plus or minus 1 is 68%. What's 2? Anyone know? Megan, you know?
Isn't it like 97%?
95%. Very good. Close enough. Okay. So plus or minus 2 standard deviations is 95%. So when we talk about 95% though, in terms of value at risk, that's on a 2-sided tail. What does that mean? I'll kind of show you. So if this is our expected outcome and we go out 1 standard deviation, then 1 standard deviation gives us about 68% of the possible observations. So if I was going back to my coin flipping and 5 was the standard deviation, so this is the mean. And if I told you that the standard deviation was 5, then that means somewhere between 45 and 55. If you said, hey, I'm going to throw up 100 coins, how many tails are going to come up? And you said, I don't know, but it'll be somewhere between 45 and 55. You would be right about 68% of the time. Now, you could be wrong. This is what's called a 2-sided tail. So you could be wrong either because fewer than 45 came up, or you could be wrong because more than 55 came up. And what's the probability of being wrong on the low end? All right, Clay, you're up. This is nice. I just go across my box here. What's the top half probability?
Is it something like between 2 and 5% or something like that?
Tell me again.
Something like 2 or 5%, somewhere around there.
No. So if we're 68 in the middle, then what do we have left on both sides? This 32. Is 1 standard deviation.
16%.
What do we have?
So you have 32% left.
Okay, so if it's split equally, we'd have what?
16 on either side.
Yes. So there's a 16% chance that it'd be lower than 45 and a 16% chance that would be more than 45. So this is what we normally look at. We're used to seeing two-sided tails, but what if we just had a one-sided tail? So what's the probability of having 55 or fewer come up? Liam's up. 55 or fewer would be what?
Would that be the 16%?
Plus the 16 is here. 16 is getting numbers like 44, 43, 42, 41 down to 0.
Oh, okay. So then it would be, do some quick math here. Be 84.
Yes. So you can see there's an 84% chance. This is a one-sided tail. There's an 84% chance that if you threw up 100 coins, you would have 55 or fewer tails come up. Okay. So this is the big distinction that we need to make. Now, normally we look at, we think about 95%. And from your old stats class, when you talk about 95%, you're looking at plus or minus 2 standard deviations. So if this is the mean and the standard deviation is 5, then somewhere between 40 and 60 would encompass 95% of the outcomes. And that would leave you 2.5% on each side. So getting fewer than 60 would be like, to get 60 or fewer would be like a 97.5% probability. Now, why is all this important? Well, what we're trying to figure out is what's going to happen to the euro, but we want to look at, and the measure they picked is kind of weird. They wanted a 95% value at risk when they did all this banking stuff. And a lot of people have kind of accepted 95% value at risk as kind of a nice benchmark to know. But the problem with it is that the 95% value at risk for us is we're only worried about one thing. We're only worried about one side risk. Yeah, because if you've got money coming in, if you've got inflows coming in, do you care if the euro spikes in value? Do you really care if the euro goes up to 140 or 150? The answer is no, because if it goes up to 140 or 150, those euros that are coming in 60 days are worth a lot more. What you're worried about is what? Euro dropping. You're worried about it going to 120 or 115 if it's at 136 right now, because this will make you sad. This will make you happy. So what you're worried about is risk on the low end. Okay. Now, in order to do a 95% value at risk, we really need to only figure out where would 5% on both tails be. So we're trying to figure out where you would have 5% here and 5% here and 90% in the middle. Okay. Now remember, plus or minus 2 standard deviations gave us 95 in the middle. And plus or minus 1 standard deviation gave us 68% in the middle. How do we get to 90? If this is 1 standard deviation and this is 2 standard deviations, then how do we get 90 in the middle? It turns out the magic number is 1.65 standard deviations. So that becomes the magic number, either minus 1.65 standard deviations or plus 1.65 standard deviations will give you 90 in the middle and 5 on each tail. So if we're only worried about the low end, this gives us a 95% value at risk measure. So the next question is, we need to figure out how something's going to move. We need to figure out how volatile it is. So most of the time what we're looking at is what is the expected volatility going forward. And most of the time volatility is given on an annualized basis. And you can actually use options to figure it out. So if we thought that the expected value was 0 in the future, and the standard deviation was 11% on an annualized basis, then to figure out a 60-day standard deviation, we take the 11% and divide it by the square root of the number of 60-day periods in a year. So if you take 11 and divide it by the square root of 6, you should get about 4.5%. Now, you don't have to worry about converting the annual to a periodic. I don't really care about that. I'll give you both. I just want you to recognize which one you need to use. So let's go ahead though, and if you I can't really go back and forth, but we've sort of read through the problem. We can kind of see, remember, we've got 515,000 euros coming in 60 days. We've got a spot rate at $1.36. We don't really know what's going to happen to the euro. So if we think it's equally likely to go up as it is to go down, we can give it an expected change at 0. And if we give it an expected change at 0 and we know the standard deviation, we will now be able to, and this is online as well, we can show what the different outcomes are. All right. So if we look here, we've got 515,000 euros coming in 60 days. If we expect no change, then we expect the euro to be at $1.36. But we know that it could go up or down, and depending on how many standard deviations we want to do, plus or minus 1 standard deviation would put 68% likelihood that the euro would either be 1.2988 or 1.4212. Okay. Now the question is, how do we get these numbers? Well, if our standard deviation is 4.5%, and the expected value, so here we are at $1.36 today, and on day 60, we don't know what it's going to do. It's going to jump around. But where is it going to hit? Okay. We don't know where it's going to hit. If it's equally likely to go up as it is to go down, kind of like flipping coins, equally likely to get heads as you are tails, then our most likely outcome is it's going to be somewhere around where it is today at $1.36. That's the expected outcome. Now, how do we figure out where the standard deviations hit? Okay. Well, if the standard deviation, if the mean is 0 and the standard deviation is 4.5, okay, that means if we go plus 4.5% or minus 4.5%, what's the resulting dollar value of the euro? Oops, I already saw a mistake on here. 60 days. Cross that out. All right, so the next question is, how do we get the 142.12 and the 129.88 that show up there? All right. Bree, any idea?
Can you repeat the question?
How do we get the 142.12 and the 129.88? That is the two possible values that are either one standard deviation higher or one standard deviation lower than our expected value.
Well, you have to calculate how much the standard deviation is.
So the standard deviation is 4.5%.
So you calculate what that is compared to 1.36.
Yes,
And then add plus or minus.
sure. Yeah. So if you take 4.5%, 0.045 times $1.36 is basically 6.12 cents. So it's either going to go up 6.12 cents or down 6.12 cents from your expected value. And those two numbers basically will give you a 68% chance of where the euro will be in the future. What if you wanted to do two standard deviations? Well, two standard deviations, if one is 4.5, two would be 9. So if you wanted to be 95% certain, you could go out two standard deviations. And 9% more than $1.36 would put you at 148.24. 9% less than $1.36 would put you at 123.76. Now, what that would do is that would make you very, very certain about what would happen. In fact, you'd be 95% certain, and that would only leave you 2.5% on each tail. Now, we don't need that much certainty. We don't want to be 97.5% certain. We want to be what? 95% certain. So we're willing to give up some of the probability because we're only worried about movements in one direction. So if you want to be 95% certain on a one-sided tail, oops, then you only need to go out 1.65 standard deviations. So the 1.65 standard deviations basically says, hey, if our standard deviation is 4.5, what's 1.65 of those standard deviations equal to? All right, Lou, you're up. Any idea? Lou may not be with us. All right, Dilly, are you there?
Yes.
All right. How do we get the 1.65 standard deviations? At 7.425%, which gets us at 125.9 as a worst case scenario.
165. I don't know.
Okay. Well, think about it. We want to go down one, not more than one, but less than two. Okay. So one standard deviation was 4.5%.
Yeah.
Two standard deviations is obviously 9% away from our expected value. So how do you think we get 7.425%?
It's from
You just take what? Try 1.65 multiplied by 0.045. What does that give you?
$1.65 multiple 105.
1.65 times 0.045.
Zero point 7.4%.
7.425%.
Yeah.
So now we can see what? Hey, 1.65 standard deviations is basically what gives us 95% of the observations. And this is our value at risk over here. Okay. So we're 95% certain that the euro won't weaken by more than 7.425%. Okay. It can go up as high as it wants, okay, because that doesn't bother us. Okay. But the 7.425%, yeah, is basically our worst case scenario, that the euro weakens by 7.425%. So what you're trying to figure out is, you know, the euro can go up or down over time. We just want to figure out what's the worst case scenario that it goes down. Yeah. But the worst case scenario is that it goes to zero. But it going to zero isn't going to happen. Yeah. So we just have to define sort of the bad case scenario. Well, how bad does it have to be? Well, we want it to be like only gets outside this range 5% of the time in our lifetime. Okay. So that's what the 95% value at risk measure is trying to figure out. Okay. How low can the euro go? If the expected value or expected change is 0 and the standard deviation is 4.5, then the 95% number is going to be 1.65 standard deviations away from the mean. All right, any other questions? You can chat me if you want, but now that we're not screen sharing. All right, let's go back to the screen share then. Are we okay on this? If you can get this negative 7.425%, if you can get that, oops, doesn't do well, then that's really the most important thing. That's sort of like your maximum loss. All right? So basically your transaction, if you talk about what's the most you can lose, the most you can lose with 95% certainty is 7.425%. So if you talk about a 515,000 euro receivables, those receivables are expected to be worth $1.36. The transaction's expected to be worth 700,400. Yeah. But if you take 700,400 and multiply it by 7.425%, then you should get 52,005. So 70,400, excuse me, 700,400 times 0.07425. should be $52,005. Okay. That's your value at risk. Okay. And you can see it because if the euro weakens by 7.425%, the euro will drop down to $1.259, at which point your transaction would be worth $648,395. And the difference between these two numbers is this one. Okay. All right, does that kind of make sense or not? Let's go back. All right. Questions? All right, let me write this out for you. Here's how I would write it out, kind of. So I want to know what's the expected value of 515,000 euros in 60 days. So here I am. Right now I'm at $1.36 per euro. I'm going to go out here 60 days. Since I expect there to be no change, actually, let me start. I don't like that starting spot. I expect there to be no change, so I don't know. It could go this way, it could go this way. But on average, I expect there to be no change, so I expect it to be worth $1.36. Now remember, that's just talk like throwing 100 pennies up. I expect there to be 50 tails. It's just terminology we use. Yeah, there's only an 8% chance there'll be 50 tails. What you really mean is I expect the euro to be trading somewhere around $1.36. Okay. Now, what I'm worried about is down here. I want to go out 1.65 standard deviations. 1.65 standard deviations means the euro could weaken by 7.425%. That's the worst case scenario. Anything above that should occur 95% of the time. So my value at risk is really, I'm comfortable saying the most I'll lose relative to what I expect. Now remember, what do I expect? I expect 515,000 euros to be worth $1.36. I expect the transaction to be worth $700,400 in 60 days. What's the worst case scenario? What's the value at risk? The value at risk is that I expect 700,400. could drop by as much as 7.425% at the worst case scenario. Or I could be worse off by about $52,005. So by taking on this transaction, I was happy to conduct the business. By taking on this transaction, I'm exposing myself to at most about $52,000. Now, is $52,000 a big deal? That's the question. Okay. $52,000 to one person might be a big deal. To someone else, it might not. Okay. So again, it's all relative. Okay. If it turns out to be a big deal, then we're going to hedge it. If it doesn't turn out to be a big deal, at least we know how much exposure we have. All right. Look at this next one. This was B. Somehow I got changed to E. There it goes. Let's look at this next one. Now, instead of being net inflows, now we have net outflows, which means we'll have to pay. So we're going to pay in 90 days. We're going to have to pay 320,000 euros. Now the question here is, what are we worried about? Are we worried about the euro strengthening or the euro weakening? Remember, when we were receiving money, we were worried about the euro weakening and getting less money. Now, if we have to purchase 320,000 euros, what are we worried about? Euro strengthening or weakening? All right, Lama, you're up.
Yes. Strengthening?
Strengthening. Because if it strengthens, we're going to have to do what? Pay more money.
More.
Yeah. So if we're right now at $1.32, if we're right now at $1.32 per euro, okay. And again, euro goes up, goes down. Here's where we are. Now let's look on day 90. Where are we going to be? No one knows. Okay. And remember, volatility can change over time. Okay. Things can be calmer. They can get. So people often use the options market. We didn't get into it yet, but they use the option market to figure out what the implied volatility is. Okay. And that's where you get something like this. Okay. So if it's 12% is the standard deviation, that's on an annualized basis, we can calculate what it'll be per 90 days. Okay. So if I told you that, and I'll always leave the expected change at 0, because you'd have to have some bias whether you thought something was going to go up or go down. But if the expected change is 0 and the standard deviation is 6, now what we're worried about is up here. We don't care if it goes down because it costs us less. That makes us happy. Okay. We want to figure out what our risk is. Okay. So we've got to figure out what's this point that encompasses 95% of the observations. All right, Brandon, you're up. How do you think we're going to get to that 95% value? I'll give you a hint. It's 1.65 standard deviations away from the mean. Brandon?
I'm not really sure how to do that.
Well, if the standard deviation is 6%, what's 1.65? Well, think about it. One standard deviation would be 6%. 2 standard deviations would be 12. What do you think 1.65 would be?
Yeah, 9.9.
Very good. All right. So 1.65 times 6% would put us at 9.9%. So now what we can see is we might end up paying 9.9% more than we thought. That's kind of our worst case scenario. So what do we think we're going to pay? Well, we think we're going to pay $1.32 per euro. And we have to pay, I forgot what the number was, 320,000. So we owe someone 320,000 euros. We kind of expect to pay them $422,400. But our value at risk would be paying them 9.9% more. And what does that turn out to be? $41,000, I'll just round up, $818. All right, let's see if we have any questions. Questions? So that was number B. You can actually probably see it. So if you look back on that handout, here, I'll share it with you real quick. If you look back on that handout here, you can see where we are. We expect, oops. We expect to pay 422,400. The worst case scenario is 1.65 standard deviations away from the mean, which would result in a 9.9% increase of what we expect to pay. $41,818 more is our value at risk. Any questions on B? Make sense? All right, now notice I stopped using accounts receivables and accounts payable, and I started using inflows and outflows. And the question is why? Well, let's go back and look. If you look at the third question, the third question says something like, I don't even know what it says. Suppose you have the following inflows and outflows. Oops, hold on. Suppose you have the following inflows and outflows over the next month. So I've got 10,000 or 10 million euros coming in. That's accounts receivables. But I have 15 million in accounts payable. So I don't really have a lot of risk because what? I'm going to use the accounts receivables in euros to pay for the accounts payable. But I do have what? An outflow of 5 million euros. So if you think about a company like PepsiCo or whatever that's doing their business all over the world, they've got bills that they're paying, they've got stuff coming in and out. And so even though they have a lot of transactions, within the course of a month, those transactions are really going to net themselves out. Now, if they have more euros that they have to pay than they have coming in, then they have some net exposure. In this case, they have 5 million euros of exposure on the outflow. If the euro is expected to be $1.10, then 5 million euros at $1.10 is really about $5.5 million worth of exposure. And this is an outflow. Now, let's look at the same company. It's got 22 million pounds coming in and 19 million pounds going out. So that's what? 3 million pounds inflow. Okay. And if the pound's trading at $1.50, then 3 million pounds at $1.50 would be equivalent to $4.5 million of inflows. Now, this seems like a lot of transactional exposure. It's not really $10 million worth of exposure, though. Why not? Because remember, on the outflow or the payment side, we worry about the foreign currency strengthening. When we have to pay 5 million euros next month, we really have to pay 15, but we're bringing in 10. So what we have to come up with on our own is 5 million. We're worried about the foreign currency strengthening. But when we look at our pound transactions, we're worried about what? Well, we actually have more pounds coming in than we have to pay. So we'll be having 3 million pounds of inflows extra next month. In this case, we worry about the foreign currency weakening. Okay. Now, if we're worried about the foreign currency strengthening, that means we're worried about the dollar weakening up here, and we're worried about the dollar strengthening down here. And guess what? If the euro and the pound are highly correlated, then what does that mean? Well, if they're highly correlated, it means they move relatively in the same direction. So if the dollar is going to weaken, it's going to weaken against the euro and the pound at the same time. In fact, we could predict about how close that relationship would be. So let's assume they're perfectly correlated. If they were perfectly correlated, that means they moved exactly the same. If they were perfectly correlated, then we would have what? Only about $1 million net outflow. If they were perfectly correlated, then we wouldn't have $10 million worth of worry. We'd only have about $1 million worth of worry on a net basis. Okay. 5.5 million outflow, 4.5 million inflow. Net would be about $1 million outflow. Okay. So what would that mean? We'd be worried about the dollar weakening. Okay. What would we want to hedge? We don't want to hedge like $10 million worth of, but what we would end up hedging is probably somewhere around Somewhere around 900,000 euros. Describe a hedge position that would be appropriate. Out of all of this 25 million euro transaction and 41 million pound transaction, we could hedge the whole thing by hedging about 900,000 euros. And we'd be hedging it relative to the fact that we're worried about the foreign currency strengthening. Okay? And we'll get to the hedge part later. Okay? So let me stop here and see if there's any questions on the net. That kind of makes sense? In fact, we could go back up, okay? And once we figure out that we only have about 900,000 euros, we could figure out the value at risk and whether it's even worth hedging back up top. Now, I started with the value at risk first. The value at risk is first figure out what your inflows or outflows are each month, then figure out how volatile the currency is. You want a 95% measure, take that volatility, multiply it by 1.65, and then multiply that by the size of your transaction, gives you the value at risk. Chapter 10, not too bad. All right, any questions on either of these two things? All right, now I got everyone here though. Let me go back and try to explain. Hopefully by now, if you go back to your Moodle page, you should see something that says Chapter 7 quiz. And the Chapter 7 quiz is an assignment, and it's due by 11 o'clock p.m. tomorrow. You download the assignment, you fill in the things, and you upload it back to me. Yeah. If you want to show work, you're going to have to scan some document in, either a blank sheet of paper, or if you can print out the assignment, you can write on it and scan it. Yeah. You can scan it with your phone, going into notes if you have an iPhone, take a picture and it'll turn it into a PDF file, and you can email it to yourself. Yeah. Once you've emailed it to yourself, you can get in your computer and you can move it anywhere you want in the computer. And eventually you'll want to do what? Move it to that upload file. Yeah. If you have a Android phone, I don't know. I mean, I would try Google Drive first. Google Drive has an option where you can take a picture of something and it acts like a scanner for free. You take a picture of something and you move it to your Google Drive account. Once it's in your Google Drive account, then you're fine. Okay, you can move it anywhere you want. All right, so that'll be due. We'll probably also have a quiz. So next week, so that's due by Thursday at 11. Then we got nothing to do for a couple days. Yeah. Next week on Monday, okay, we'll probably have, it says chapter 10 on here. I've covered most of chapter 10, but you read through chapter 10. I might come up with a couple more problems. We'll probably also have a quiz over chapter 10. Yeah. But we will also use Monday as a review day. So Monday is going to be a review day for what? Everything that's going to be on test 2. What's on test 2? Trading currencies, chapter 5. Chapter 5 was forwards, futures, and a little bit on options, not much. Chapter 7, we just went over locational arbitrage, triangular arbitrage, covered interest arbitrage. And then chapter 10 is what we did today. So Someone said there's Cam Scanner that's free. Okay, you can take a picture and email it to yourself. Perfect. Okay, I'm sure there's other ones too. But figure out some way. So on Monday, we'll probably have a quiz. That quiz will probably be due. I might post it early, but I doubt. I don't know what I'll do. Probably if I get bored, which is likely. But anyway, it'll probably be due Tuesday, the chapter, to give me time to grade it and get it back to you. And then our test will be Wednesday, April 8th. And the test will cover Trading Currencies, Chapter 5, Chapter 7, and Chapter 10. Now, I did put on, I think, I have to double check, there is something called a Test 2 review that I put up. Test 2 review, I think, has a bunch of this stuff in it. And we'll go over some of that on Monday, April 6th. All right, does that make sense? Any questions? It should take you 10, 15 minutes to do the quiz, just like any other quiz. I'm just giving you more time. Okay. The test, though, I haven't decided yet. See how we upload this first quiz. I'll let you know Monday what our test format's going to be, but it's most likely going to be something that you download and work on. So try to figure out, and you probably want to show work on the test. So try to figure out a way that you can show me work. And the easiest thing would be scan it as a PDF and upload the file to me, but we'll see.
So you said the chapter 10 quiz will be the same format as chapter 7.
Chapter 10 will be the same format as chapter 7. I'll give it, it might be posted early, I don't know. I'll give it to you Monday. It'll be due Tuesday though. But I mean, like I said, these things take you not very long. I'll probably post it earlier than that if I'm guessing. Yeah. But it's not going to be due till Tuesday regardless. Okay. And then our test will be on Wednesday, but that'll give you some time to go back and look at the quiz. And it might be even like Tuesday at 2 o'clock or something. I don't know. I mean, I give you some time with some flexibility, but that's plenty of flexibility, I think. All right. What other questions?
For the quizzes, if we work on another sheet of paper, do you want us to send that paper too as well?
Yes, there's directions on there. Basically, if you don't have a printer, okay, so if you don't have a printer, what the best thing to do probably for me would be to write the answers on the test. You should be able to upload more than one file. I can't guarantee it because I haven't done it yet, but theoretically, I set it to open, you could upload 4 different files to me, theoretically. So the one file for sure is going to be the sheet that you download and put the answers on. Okay. If you don't have a printer and you want to show work, then get out a blank piece of paper and show your work somewhere. And then you're going to need to convert that to a PDF, either by using the notes, we'll do it on your iPhone, or if you've got some kind of scanner app. And Tracy said maybe Cam Scanner's free and works. Okay. It's not rocket science nowadays to convert this stuff to a PDF file. So it shouldn't be expensive. Don't spend like $30 on it. I mean, I spent $6 for TurboScan Pro a year ago. Okay. But that's because I was scanning some stuff and I was like, oh, I'm not going to take notes anymore. I was like, but I want the good one. And so I bought that one, and it does like 100 documents. It takes 3 pictures. It makes everything clear. Okay, that's what you're paying for. You don't really need it because I'll be able to read it. It doesn't have to be perfect. We're not a legal document. Yeah, so just either use the notes or the something on Google Drive, or Cam Scanner. And anyway, you'd be amazed how neat it is. And that way, a lot of times when I go to meetings and stuff, I just take pictures. A lot of you take pictures and try to blow them up. It's a lot easier to take pictures with the scanner thing, and then all the documents are nice and organized. So it's a good tool to have for the future. or know how to do. All right, what else? All right, is that it? We're getting out early today. More efficient. All right, well, I will see you guys. Make sure, remember, when's the stuff due? Thursday. Quiz due Thursday by 11 p.m. All right, shouldn't take you very long. Just a regular in-class 15-minute quiz. All right, well, I'll stop recording and upload this to Zoom and YouTube. My YouTube channel isn't a big hit yet, but that's okay. This class at least didn't blow out the internet on us. So, all right, see you guys next Monday. Have a good weekend. Call me or email me if you have questions. Bye.